Hi everyone. Um, I just wanted to take a few minutes, probably won't take very long, but go over a few things related to callbacks that I had seen, a couple of examples, and then a couple of specific nuances that I wanted to share. And in fact, one that I'm not absolutely sure about, but maybe Arto can help us figure that out as well. So that was my goal again, just since callbacks are fairly interesting and key to the overall training loop and stuff. I thought it would be worth sharing the couple of things that I learned by watching this Mueller guy go through um, examples as well as highlight a couple of nuances that I thought were interesting. So that's kind of what I wanted to cover today. If anybody else has anything related to callbacks, feel free to jump in and share as well. So, with that said, let me share my screen and let me know if when you can see it.
Yep, can see.
Okay, so one of the things, this is a notebook that um, Mueller had provided. Unfortunately, and this is the reason that I was asking you for the thing, I didn't, I, for the initialization, had some difficulties running this notebook, but it might have to do with kind of all the dependencies and getting them aligned because Mueller also uses is walking, I think, with FastAI or this WWF. And then there are some errors about touch related dependencies. Um, so I'll try and see whether I can figure it out offline. But that's not material to what I wanted to cover. So let's look at what I wanted to kind of cover, which is something that we have already looked at is this list of events based on which the callbacks take place or are triggered. And he goes through a couple of examples which I thought were interesting, and then I'll get into the first question slash nuance that he highlights that I was not absolutely 100% confident on what are the implications, and we can discuss that. First, let's focus on just an example of what a simple callback that is a short epoch callback. So this one is just a simple callback, which we write in order to say fit for a percentage of epoch and then stop. And we can specify whatever percentage we want to we want the training to run through and then stop. So this is an initialization where we specify the percentage and then we also give it a flag which says, do you want to do this, also during validation? And if so, put the short valid flag to true. Um, this is just the initialization. And again, um, you write the code for when you want the um, callback to run, which is at after the batch. And now we know based on Arto's explanation last week and the week before that we looked at that self.iter is automatically set up by one of the by the value to be the current iteration, and the self dot n iter will be the total number of iteration. So obviously the ratio is the percentage. And if the ratio is less than the percentage, which means that our iteration as a percentage of the total number of iteration is less than, say, in this case, the percentage that we specify, 0.01, then we just continue. And that means we continue to run to the and don't start, don't cancel the training. And if, on the other hand, this condition is not satisfied, which means our iter has gone, iter as a ratio of the total iteration is equal to or greater than the percentage, then we come here and we say self-training, and we cancel the train exception. And if, of course, the short valid thing is true, then when we go into the validation, then we do the same thing. If self.short valid, then you cancel the valid exception. Okay, so this is just a simple example of a callback that restricts the or the fitting to just a percentage of epoch, a percentage of an epoch, right? So again, as I mentioned, I ran into some problems in actually running the code, which I think personally has to do with the setup and the various dependencies and stuff. But let's ignore that for a minute. And look at another example before I come to the specific thing, that nuance that he chose to highlight. Here is another typical callback that FastAI already provides the code for, and that is a tracker callback. So this callback is actually just keeps track of the best value of whatever we want to monitor that we specify in the variable monitor. So if, for example, we make the thing we want to monitor the valid loss, then that's what monitor is set to here. And it's set in actually the default value of monitor is valid loss, but obviously you could change it within the callback. And we'll see how the tracker callback is subsequently used in another example that we can use to get kind of the best model with, that is the model with the best value of the monitor that we use. So here again, it just kind of makes the code here just says, set the value of comparing to certain default values. And then here is the code for the actual callback, which says before fit, prepare the monitored value, because now since you're monitoring the value, you want to set it as either float of positive infinity or negative infinity, depending on which direction we'd want to monitor. And then track the index. Then after the epoch is done, and this is where this is all set up, and then after epoch is where we actually want to do the comparison. So we store the value of the last record of values at the index into value. And then you say if the self.compare of the value, and of course we say minimum delta because we are comparing floating point values. So we make sure that a specific delta is specified. And if the value and self.best are within a particular, within the min delta of, if the value is within min delta of self.best, then depending on which direction we want, we set the value to be the current best. That is, if let's say the value is less than our previous best, and we are tracking lower values to be better, then we set the new value, which is obviously lower than the best value thus far, and by more than the min delta, then we put the value in self.best. And we set also the flag saying self.newBest, right? Otherwise, self.newBest is set to false, and we continue. Now, so what this does is it obviously tracks the value as well as puts the new value, it sets the flag to self.newBest as well as updates the self.best to be the best value that we have found, depending on what we are tracking, which can default is validation loss. Then we come to another example which actually utilizes the tracker callback, and the tracker callback obviously can be used by multiple other callbacks that we can write depending on what we are monitoring. But let's say we look at another example, which is the save model callback. So that is that inherits from the tracker callback. And what it does, it saves the model's best during training and loads the value back into the model, or loads the best value model before we proceed to validation. So we then are ensured that we don't just exit the training loop with the last model that we ran after a bunch of epochs, but the best model that all our epochs gave us, depending obviously on the value of the monitor. So in default case, the validation loss. So here we set only train loop equal true. That is, we do this obviously for the training loop only. We do some initialization, and then we call the tracker callbacks init through the super init. And then we save the last save path, set the last save path to none. This is actually an internal thing, that is we, underscore save, which we'll call in the after epoch portion to save the path of the last model. And here is where we utilize what the tracker callback has already done, which is compare the value monitored to the best score, and we save it if it is the best. So in the else case, which means that we are seeing some improvement, then, and this was interesting to me as to what this line actually does. And anybody who has used callbacks and so on can also confirm, as it was explained, this particular thing, super, which actually ends up, I would assume, given Python, that it's calling the tracker callback. But basically, what this super after epoch does is calls every other callback other than our own callback at the after epoch. So that's what this particular line of code does. And then if we have self.newBest with the tracker callback, if you recall, has set, if we have a best or a new best, sorry, then we print this, which is to say that, hey, a better model has been found in this epoch with this value. And right. And we also call self.save, which means that, this thing, which is the last saved path, self.learn.save. And of course, this is with or without the optimizer. So what this does is it saves the particular model, loads it if the new best is set. And that's an additional thing that the save model callback does, utilizing what the tracker callback has already provided us, which is an indication through the new best flag that we have a new best model, and storing that in the save path. So that's kind of a couple of different examples of practical uses of callbacks and simple enough that we can understand. And also, this was something that I thought was interesting, that if you wanted to kind of run every callback at that particular event without our own callback, then this is the way we do it, using the super call, if you will.
Just
Any
to ask,
questions?
yeah, is that really running all the callbacks? I thought it's just going to run like the tracker callbacks after epoch to get the current best. And then as soon as it gets the current best, no new best to be set to a new value, then it will now proceed to run after
Sorry,
epoch of.
could you repeat that, Tendo?
Yeah, I just assume that this super dot after epoch was supposed to run the after epoch of the tracker callback for it to like update the new best if there's a new best. Yeah,
Right.
because you know that at this point in the just before the super dot after epoch, we don't have like the updated values in the recorder. We don't have it like we haven't set a new best or anything like that. So we just call super to set it
Right.
first.
That would be my understanding too. For some reason, he mentioned, and that's the part which I guess you would have to run with some examples to see whether, if there are other callbacks besides the tracker callback that are also supposed to run after when this event happens, whether those are run. um, because typically, again, as you saw, as we see here, the super dunder init is just initializing based on, the super call just kind of goes through the hierarchy of inheritance and calls the initialization, which is what this does. But he specifically mentioned that this super call runs the, all the callbacks at after epoch other than um, the same model callback itself. So that's a fair question as to which of the two things happen. Is it because we could potentially have other callbacks, not just the tracker callback, but other callbacks that are also supposed to be run or have methods that have an after epoch method. Any insight, Arto, on which of these two things that we are discussing actually happens? I haven't run experiments to see which of those is.
Oh, sorry, I was like not completely with you here. If you could briefly
Sure. So
repeat.
see, one of the things that, as I went through the examples, and one of the things that Mueller talks about is the impact of this particular line of code in uh, the same model callback. His statement in the lecture that or in the talk that he gives, and I'll post the link to that as well, is to say that this super after epoch runs all the callbacks corresponding to after epoch event, but not the except the same model callback itself. So, for example, it would definitely run the tracker callback, and according to him, if he and he explicitly mentions this at least twice, it would run all other callbacks that have this method as well when we do this. And as Tendo raised the question that, for example, when we do super.init, dunder init, it typically means you just go up the hierarchy and run the tracker callback initialization to initialize these things, right? So following that line of thought, then the super after epoch would seem to imply that you would just run the tracker callback after epoch method, not the after epoch method of all the callbacks, meaning any other callback that is also having the after epoch method.
it makes sense, but yeah, really, I don't have like specific insight on this. I
Yeah.
never saw it like happen that you want to run all the callbacks. Yeah, basically, all the callbacks are called when you run when you call your learn object with after epoch, right?
Right.
And yeah, potentially, if this call somehow does that, it would run all the other callbacks with after epoch, but I don't see how it's happening here.
So that's
My arguments would be like, let's say you had something like, since we're monitoring loss, let's say you had something like, let's assume we're monitoring training loss. You have something like gradient accumulation that actually affects the loss values. Yeah. You would set an order to it for it to run like maybe after a step. Let's just assume it's going to be the first callback that will be run. So after since you know gradient accumulation divides the loss value, when that happens and then it now gets to the same model callback, if you should actually run super after a program, expect it to call all the callback, that means to run the gradient accumulation again and divide the loss. I don't know if you guys like follow my thoughts process. So basically repeat that step or repeat that callback again, which is why I feel is this the after epoch is just for tracker callback and not all the callbacks.
Yeah, it makes sense. Maybe like we are like maybe we are misinterpreting what Zach said in his video. I haven't watched it, so I'm not sure what was that all about.
yeah.
And
So worth checking out. But anyway, that's he kind of mentions it a couple of times, saying it runs all other callbacks, and I was puzzled by that as well. And so it's a good, but I would have expected what Tendo said, which is what, and again, I point to this super dot in it because that's kind of what the same. But on the other hand, the thing why I hesitate to say which it is with certainty is because of the nature of the events and the interrelationship with, like you said, the learn object and what is run, and does it run the, when we call this, does it run, and ultimately the proof would be for us to try with an example, which I haven't had the chance to do. So I think that's probably the best thing to do, and then post on Slack or something as to which of the cases. But I also see what Tendo is saying, because if we were to uh, do what he said, then this would imply that we would again, if something is run, then it would run again. But then that the question I would have is whether that gets sorted out by the ordering aspect of callbacks.
yeah, the thing, one thing is this is after epoch event. So basically, after epoch event should do some cleanup, like calculate the final loss, right? And yeah, and update the state if the last model is new best.
Right.
So yeah, but I don't see why we need to run any other callbacks than tracker callback after epoch here, and why would it happen? Yeah.
Okay, which leads me, actually, let's look at one more example so that we finish up the examples before we go to the other issue that I wanted to highlight that he mentions, that I'm again not 100% certain of how the details are. So this is to reduce the learning rate when we plateau. So if, for example, the loss plateaus, that means it doesn't change for a while, then we have kind of hit a plateau or a flat region of the loss manifold, and therefore we want to reduce the learning rate in order to see whether we are able to further go down, if you will, on the loss landscape. And so here, when a metric has stopped improving, you want to see whether you can reduce the learning rate. The typical thing here that you do is you have a value called patience. That is, you don't kind of reduce the learning rate as soon as a metric stops improving, but you wait for a little while, let's say 5 cycles, 5 epochs, and if it doesn't improve in patient's number of epochs, then you kind of, or patient number of whatever iterations and epochs, then you kind of proceed to reduce the learning rate. So that's what this patience factor here is. The monitor and the minimum delta and other things are stuff that you are already familiar with. The factor is the factor by which you reduce the learning rate, and then you also have a minimum learning rate so that you don't reduce the learning rate below the minimum learning rate. And then you have a flag which says, do you want to reset this on fit? So you set the variables, and then when you do the before fit, you just say set the weight variable to 0, and then you run before fit. So again, you can see super call before fit here, and then after epoch, what you do is compare the value monitored to its best score. And then if there is no improvement for patients, number of things, then you reduce the LR by the factor. So you do the after epoch thing, set the value if there is a new best, because remember that a new best says that, hey, the value has still changed and gotten lower, assuming lower is better for us. Then you want to set the weight flag to 0 because you want to count from when the last change happened. And then you begin to increase the weight, and then you compare the weight to patients, and you kind of store the old value in of the hyperparameter in old LR, and then here is where you change it for H in self.hyper. You kind of set the max divided by the factor, or max of the hyperparameter learning rate divided by the factor, or self.min LR. So you don't want to go below that. You want to choose between either the learning rate reduced by a factor of 10 or the minimum LR. And then again, because you have done that and you will continue, so you again set the weight flag to 0. And here you just say, you print out saying you are doing the reduction of LR. Okay, so that is the reduce LR on plateau callback, again inheriting from the tracer callback. Right. So now we've seen enough examples. I guess one more example of early stopping. Early stopping is again terminates training when the monitored quantity stops improving after waiting for patient's number of cycles after the last change. So given the various examples, I think you can kind of understand what it does. You set the weight to 0, and then you begin to increase the weight, and when it's greater than patients, if there is still no improvement, then you raise cancel fit exception, which means you stop when there is no more exceptions. So those are various examples, and again, if you can kind of try to code each of these yourself, and then compare to what has been provided, that would be good exercise to kind of understand what you need to do in order to be able to code various callbacks. Now, that said, the first kind of nuance that, again, Zach highlights that I wanted to kind of uh, touch upon is if we go back and look at the callbacks, and let's say we are just doing the short epoch callback, one of the things that he talks about is you can provide the callback in the learn or in the learner itself, like you do here, right? So you're saying that the callbacks are short epoch callback in the learner, in which case the point he makes in the discussion is the fact that this is part of the learner. So if you don't want it, if you don't want these callbacks to be active during any different part of the fit cycle or outside the fit and so on, um, for example, in the validation portion versus the training part and so on, then you need to actually remove the callbacks. And obviously, we have seen, I think Arto covered this as part of the learner code. Is there's code for, I forget what it is called, but for removal of callbacks. Now, on the other hand, his point is that you can also provide the callbacks as is done here. Of course, this is for fit one cycle, but even here in learn.fit, you can provide the callbacks. And if this is the case, then it only works within the fit cycle. Right now, this is where, again, I wasn't absolutely certain or sure of the differences and the implications of what are the differences and what are the now he does give one example of a use case where you would potentially want the callbacks in the learner itself, like here. Otherwise, I think given the shortcoming that is highlighting, I would have thought that you would always want then the callbacks to be part of the learn.fit. And why would you then, if you need to go back and actively remove callbacks, why would you make the callbacks part of the learner? Any comments or insights into this kind of difference of specifying callbacks in the learner versus specifying it as part of the learn.fit, Arto?
The only difference is that if you specify it in fit call, it will be properly removed after the fit is finished, and it might be relevant to some callbacks which you want to like have attached to your learner after the fit is finished. For example, if you say use activation stats callback, you want to have access to the stored statistics probably after the fit is finished. So and I guess if you like pass it to the fit call, it will be removed, and you won't be able to access this information, so it would like make it pointless. So you would rather pass it to the learner.
Okay, because yeah, in fact, the example he gives, and I'll get to that shortly, is similar to what you said, which is that if you want to, in an example he gives is if you want to call learn.fit multiple times, then you can't do that unless you put the callbacks in the learner. Because if you want, after your first call to learn.fit, your second call to learn.fit no longer has the callbacks.
Yeah, and on the other hand, as far as I know, some callbacks might be better like put into this fit call because you want them, you don't want to have them, for example, when you do learn.export attached. I think it's relevant for example, weights and biases callback, maybe some other callbacks.
Yeah, actually, one example to your point also that he raises is, for example, one of the things why you may not want it in the learner is he says, let's forget for a minute that the short valid is true flag exists, right? Let's say that it does, we don't set that and we use the short epoch callback. Then his point is that if you put the short epoch callback here, then it would be valid, or it would go into effect both in the training loop and in the validation loop, which you may or may not want. Right. Whereas, but I thought that example wasn't great because you can control it using the flags that he has illustrated in the example of the short epoch callback anyway. Right. But I think your example of like activation tracking, which you need outside of it, is, I think, a much better example in my mind. But I just wanted to highlight the fact that, which to me, I hadn't kind of absorbed this nuance of, you could specify callback in the learner or you could specify it in fit. And there are reasons, I mean, again, like you said, Arto, it seems like you would typically want to put it in fit because then it kind of auto removes them outside of fit. But there are cases where you may want to put it in the learner as well.
Yeah, just pointing back to something that I pointed out. You mentioned something about exports. So I started wondering, does FastAI save like the callbacks when it's like with the PyTorch model state dicts? Are they included, the callbacks themselves? When saving a model, I know like things like optimizer state are included. Things like what else now? Maybe the data loader states. I don't know if callbacks are also included. I'm looking at the source code now, but I can't see.
If callbacks are what, Tendo?
Are also included when you're exporting a model. Like if the callbacks that were used in training are also included. I know by default, like things like the optimizer state are included. Then things like the data loader states are also included. That's when you're calling len.exports.
It would be.
Yeah, so I was wondering if callbacks also include. Then if it's included, then that means that we should usually always specify the callbacks when we're defining CNN learner, because that's the only way to get included. Yeah, so I'm not sure that's what I just asked.
Yeah, but as Arto was saying, I think, Arto, correct me if I'm wrong, but the default, I would think, given what we just discussed, would be, or the default meaning the preferred thing would be to put the callbacks in the fit, right? Learn.fit.
Okay.
From my point of view, like it depends on the callback you use, and also like probably in a lot of cases, if callbacks are created properly, and that shouldn't make much difference. But yeah, in some cases, you want to make sure, for example, that there is no callback attached to the learner, which carries like some extra information and might have some extra memory associated with it and would be like exported if you do laundry export. And on the other hand, you want to make sure that some callbacks that is essential to like making your training loop work are always there. And also, yeah, there are some subtle like use cases when, for example, you call LR find. You want to have your like necessary callbacks in place. So, and I think that's why that like is valid or something flag exists. It might be useful for some of these cases, probably, which is like specified when you create a callback. You can specify you can specify an order and some other attribute on callback, which is well, like binary value.
Yeah, like this after train thing we saw, forget where, maybe not after train, but this only train loop equals true flag, right?
Yeah.
Yeah, but
Yeah, so,
I mean, the reason I touch on this was something at least that I didn't catch until I kind of poked around through his and listened to his lecture and kind of learned the subtleties, or what or what not, or why or why not, of specifying callbacks in the learner versus specifying the callback in learn.fit.
yeah, and I just like somewhat irrelevant. I was trying to, like right now I'm somewhat distracted because I was trying to train Hugging Face model with FastAI using this blur library, which is like a wrapper to make it work, like to make FastAI training loop work with Hugging Face models. And it relies on callbacks and it relies on callback and like model wrapper. And because something was recently changed in FastAI training loop, right now this blur library is broken.
Yeah, that's the one thing which, I think even as I was going through these lessons, I periodically would panic and things would crash and burn, and I'd be like, oh gee. And then I learned over time that if I need to reload, or things have changed underneath me on fast core, even for and fast AI, so it keeps changing.
Yeah.
Which
And yeah, so it's sometimes it might be like not very good for library, because if you want to use it if you use it in some way that you want to be able to rely on it, yeah, sometimes it might be difficult to keep up with these updates.
yeah.
And
Yeah.
like some updates are related to removing some bugs or like making it working better, but other updates are just like, and it might be in one release, so probably yeah, you need to like always be careful with what's going on with FastAI.
Yeah, and also, I mean, from a research perspective, if you're trying, then I can understand, because you just kind of like say, oh, I need to pull, and sometimes things aren't quite in sync, as you mentioned last time as well, and PyTorch and fastcore compatibility gets out of whack and things like that. But in research, doesn't really matter, because you just kind of go pull and get the thing worked out, and then you keep going. But as you said, for a little more stable thing, or and the other thing which sometimes I've had problems with is, at least I tend to save things and say, oh, okay, I understand, and if need be, I can go back to it. But then when I go back, the thing no longer works. That's frustrating too sometimes. But oh well, that's nature of the game, fast moving stuff. So this learn, this callbacks in the learner or callbacks in the fit is something that I thought was worth highlighting, because at least, it wasn't in my face before that these things have different implications. And like you said, it kind of depends on what you want to do with them, of where you put it. But at least I didn't quite grasp that importance previously. And this one, at least now I'm aware that that could have different things happen depending on where you put the callbacks. So that's one of the key nuances that I wanted to call out. The second one, which he, again, this is based off of a Mueller notebook, where he uses a callback to support teacher forcing. And again, I'm assuming, let me open that notebook and then we'll talk a little bit about teacher forcing. And there's another thing that, another nuance or key item that he pointed out as part of the that example that I think is also worth highlighting, because again, I was, while I vaguely understood it, but I think it kind of forced me to internalize what it means, just like being able to specify callbacks both in the learner and the learn.fit. Give me a minute while I open that. Sorry, I'm still in quarantine and therefore stuck on my laptop. It takes a while for my that took a while. So talking of teacher forcing, so basically, if you are not familiar, I assume Tendo, Arto, and so on are familiar, but just to set the stage, I think it is typically in language models, for example, and the example he uses is a seek-to-seek model in this case. But basically, what you're trying to do in teacher forcing is to say that if, for example, you are learning a language model, then you want to provide the next output as the input to the next slice, if you will, with respect to the input, so that in each case that the target is your input shifted to the right by 1. So that's all you're trying to do, which is it's kind of self-supervised learning in the sense that the target is whatever is on your right by 1 index. And that's all it is. Now, what he's trying to illustrate in this example is to say that you can, with simple use of callbacks, create the situation in FastAI where you can simply make the target part of your input. And how you do that is what he illustrates with the use of the teacher forcing callback. So, the teacher forcing callback, again, you inherit from callback. Basically, what you're trying to do is a y value is something that you want as part of your x value, meaning your target you want as part of your input. That is, your input shifted left or right, becomes part of what your target, or your target become part of what you want to provide as input to the model. And typically you don't have that, meaning your input is just x, it's just a simple x value, but now you want the target to be part of your input as well in seek-to-seek models, where you're doing teacher forcing. So here again, you can specify a ratio of 0.5, which is what you made the teacher forcing stuff for. So forget about the before fit. This is something that I'll get to in a minute, but pretend that these lines don't exist. Then typically in the teacher forcing callback, all you do is before you do the batch, you take the x and the y and just dump them into the x and y value. And now what you do is you create the new xb, which is the x batch of the learner, to be the combination of x, y, and whatever self-taught teacher forcing ratio is. So by the simple act of coding this callback, you have now taken the y, the x is already available to you, and taken the self-taught teacher forcing ratio and make those part of your x that you can then use in the model. Okay, so that's kind of, think of it conceptually as, well, I want the target, but in this case, I want the target to be part of my X that I'm then providing to my seek-to-seek model. How do I do that? Well, you can do that simply by creating a callback, taking the X and the Y values, and then shoving the Y value as combining, if you will, the X and the Y values and something else, which is the teacher forcing ratio, and then putting that in the new X value that you then use in your model. So that's kind of, he just wants to point out that here's a simple example of how you can conceptually play with your inputs and outputs using callbacks as well. Now, having said that, there is one other nuance that, at least again for me, as he illustrated, was insightful that I wanted to share, which is, remember that callbacks are independent of each other, right? So each callback is an entity by itself. It cannot access what is in other callbacks. So for example, if let's say, and again, this is just a made up thing, but let's say we want a student forcing ratio or a student forcing callback, and that callback, for whatever reason, needs to access the teacher forcing ratio, which is there in the teacher forcing callback. It cannot by default do that because each callback is independent. Now, the way to kind of work through this is to say, and I think Arto had covered this in the code, if you will, of the learner, but at least to me, this example reinforces how you do that is by storing the values that you want to be shared in the handler or basically in the learner. So that's why, for example, now this lines of code, if you put the teacher forcing ratio, which is the self.teacher forcing ratio of the teacher forcing callback, into the learner, then you can access the self.learn.teacher forcing ratio in the student forcing ratio callback. So the principle being that anything that you want multiple callbacks to have access to is something that you need to store in the learner. And that's a way that the callbacks can kind of communicate with each other through the learn object.
Yeah, but I think here is like an interesting point for discussion. So this way of communication implies that the first callback is created with the second callback in mind, right? So we need to know in advance which attributes do we need to store in learn object.
Mm-hmm. Yes, you're right.
And yeah, another way would be just to like subclass this teacher forcing callback and add before fit method just to like override it. Yeah, but I think it should be possible to access the attributes of another callback by accessing it by name, right? So if we do teacher forcing callback like learn.teacher forcing, and if we have this teacher forcing ratio stored in a teacher forcing callback.
Mm-hmm. So you're saying you would potentially be able to access it in another callback by using the name teacher forcing callback dot teacher forcing ratio?
Yeah, right. So each callback is assigned to the learn object by its name. And I think teacher forcing a name would be teacher underscore forcing. So learn teacher underscore forcing should be an attribute by which we can access teacher forcing callback.
So within that, whatever variables are, you're saying you can use the name of a callback. So you could, to repeat, you're saying you could do learn dot teacher forcing. If the name of the callback is teacher forcing, then learn dot teacher forcing ratio from another callback would give you access to that value.
Yeah, and in such way, I will not need to either
A priori,
redefine
no.
teacher forcing or to have this everything a priori
Known.
like
Yeah.
predefined predefined all the possible use cases. So I will only need to work inside my new callback, not inside the old one, which potentially is made by some other person, and I don't want to mess with its internals.
Interesting.
But yeah, I'm not sure if there is something limiting here. Maybe there is some reason not to do what I've just suggested, but
no, that seems in fact to be a simpler way than, like you said here. This implies that when you want, I mean, as you mentioned correctly or highlighted, this says that if I come up with a callback which is dependent on something that has been previously coded, and if the other person has not stored the value, which, like, as I said, even in this example, I went back and added this. So if I didn't add this and I just had that, then, like you point out correctly, you would need to go mark with somebody else's code. Whereas your approach says, well, I just go in and access it using the name. So if that works, then that is a simpler way than what he has illustrated.
Yeah, I just think it would be like cleaner
Yeah,
and
yeah.
less like prone to
Dependency.
some
Yeah,
potential errors.
yeah. That's good. That's another important thing then that I learned today. Thanks, Ato. Because this was something that I thought was interesting as to how you could access values, because callbacks are independent, and if you want to share, then, and I think the way you pointed out is probably even simpler than this. I'll make sure to capture that here in the documentation as well. That's cool. So those were kind of the examples and the nuances. One is, if you want to share, what do you do? So at least we have two methods. I'll call it, for lack of a better name, the auto method, of just accessing another callback through the name of the callback and then the variable, or storing it in learn. But that has issues, as Arto pointed out, that you would need to know ahead of time, or you would need to go back and change somebody's code. So actually, if you can access through name, that's probably a simpler and more cleaner way of doing things. And then this thing of, depending on what you want the callback to do, you should put the callbacks in either the learn.fit, remembering that then the callbacks get removed once the fit cycle is done, which is good. But if you want it to stay around, then you put it in the learner itself. And those are the two different kind of use models that you need to keep in mind as to where you want to put it. And those are kind of the different nuances of callbacks that at least I wanted to touch on, which were new and interesting to me beyond what we have already looked at.
Just to be clear, it will be something like looping in the callbacks and then searching for the name you want to get and accessing the attribute directly, or store the variable before the call to the learner and then use it inside your callback, or how? I'm not so sure.
Oh, I think he meant like instead of doing this whole trick where we have like before fits equal to self dot let dot teacher first name equal to self. Yeah, instead of doing all this, like, because when you're doing this, you have to have in mind that maybe the next callback you're going to use is going to need to access this teacher first name ratio variable. Now, instead of doing this, you could just, in your student first name ratio, you can just have self.teacher first name ratio is equal to self.learn.teacher first name. So the name of the callback is teacher first name callback.
Yeah.
By default, FastAI changes it to like teacher underscore first name. It's not the teacher underscore first name dot teacher first name ratio. So you save yourself like stress of writing before fits and teacher first name callback itself.
Right.
So it's a really nice trick. Yeah.
Yeah.
Okay.
And then you don't need this whole set of things. Then because you have the access to the name, which is this callback, and within that callback, you can now access whatever variable name you want. That's kind of cool. Actually, it is simpler and more cleaner, as Ato just said.
Yeah.
Okay, so those were kind of the few points that I wanted to highlight because they were interesting to me and kind of highlight some, and as Arto has also expanded on one an even easier method, if you will. So that's kind of cool. Anything else that anybody wanted to share or highlight with respect to callbacks? Okay, if not, thanks for joining. I'll see if there is anything else interesting. Keep an eye out. Also, as I mentioned before, I'll be shortly, I think later today, posting a call, if you will, or a poll on potentially starting a study group in a few weeks on self-supervised, semi-supervised learning based on that Berkeley course. So if you see that in the general and if you're interested, please chime in. I think that is an area that I feel will become, if it's not already in the last year and a half, becoming much more important. So I'm interested in learning that. And if you are, please chime in. I'll post that on a couple of different channels, and I'm thinking that we can use this slot between on Sunday mornings at 8 o'clock as we are kind of coming to an end with respect to the FastAI, but there's still 3-4 weeks left before we switch over. So if there's anything else in FastAI that you'd want to spend time on, let me know. We have a few weeks before we switch over, or at least see whether there is enough interest in that. So if you're interested, please do vote.
Yeah, that semi-supervised course sounds great. So
yeah.
Looking
okay.
forward.
Sorry, Arto, go ahead.
Yeah, I just finished. I'm saying that I'm really interested in that self-supervised course. So that should be fun.
Yeah.
There is a course you want to follow, or will be like more like try and error?
Sorry, David, go ahead. What were you saying?
There is a course you want to follow, or
Yeah. There's a
okay.
Berkeley course taught in 2020 that I can send you a link of that I'm thinking of following. It's about 12 lectures with some homework and other things on self-supervised, semi-supervised, generative, those kind of things. Yeah, okay. There's a Berkeley course on it. I'll send you the link offline.
Okay.
Okay, thanks everybody for joining, and have the rest of the morning. Have a great weekend. Sure thing.
Thank you.
Thank you. Bye.
Thanks.
Bye.
Bye.
Thank you.